Hey, this is Brian with Radical Prep. We're doing questions for the new 2016 SAT, the one that comes out in March. And this question is from the College Board website. And I think it's actually a tough question, and I've got a nice sneaky way for you to get it right. Let's read it. The gas mileage for Peter's car is 21 miles per gallon when the car travels at an average speed of 50 miles per hour. The car's gas tank has 17 gallons of gas at the beginning of the trip. If Peter's car travels at an average speed of 50 miles per hour, which of the following functions F models the number of gallons of gas remaining in the tank T hours after the trip begins? Alright, so I'm already getting tired reading this. It's a mouthful, and I'll be honest, if I was your age and I was taking the SAT, this could be an intimidating question. But we've got some nice little tricks, nice little things we can do to get this right. First thing I want to tell you is what I tell my students is to underline what the heck are we trying to find. Right? So we're looking for the number of gallons of gas remaining in the tank after T hours. So how much did we start off with? Can you tell me? Do you remember? Well, hopefully you said 17, right? And we're going to minus, what are we going to minus? Well, I don't know exactly what the rate or the units are going to be, but we're using some amount of gallons of gas. I'll put gallons used per hour. It's kind of like the most basic way I can put it. You start off with 17, and we're getting rid of some amount of gas per hour, or some gallons per hour. So here are the nice tricks. Look at choices C and D. 17 is by itself. That's not going to change. It's a standalone number. So we're getting rid of C, and we're getting rid of D. So now we got a 50-50 shot of getting it right if you're just going to guess. Okay. So before I show you the mathematical way of getting this while trying to figure out is it 21 over 50 or 50 over 21, let's try and reason this out. Sometimes you can actually get the right answer by reasoning. So let me ask you this. Does it make sense that the longer you drive, the less gas you should have in the car? It should, right? Well, what happens if he drives 1 hour? Well, both of these equations, he's going to lose some gas, right? In this one, he'll lose a little bit. In this one, he'll lose more in choice B. But what happens if you drive 100 hours, okay, or a really, really long time? Look at choice A. If the numbers in the denominator get bigger, so let's just pick on this one for a second, 21 over, let's say 10 hours. Let's not even go crazy. So in 10 hours, this is a really tiny fraction, right? 21 over 500. So in 10 hours, he still almost has 17 gallons. Does that make sense to you? That should not make sense. So choice A is gone, and that's my sneaky way of getting this right. Now, and that should make sense because in choice B, if you drive 3 hours, you're losing a decent amount of gas. 10 hours, you're losing a lot of gas. But in choice A, the longer you drive, you're actually losing less and less gas because your fraction is getting smaller and smaller and smaller. Or I should say, the denominator is getting bigger, making the fraction smaller. Let's say you had no idea what I just said, and you're going, Brian, what the heck did you just say? Let's go back to the original part. 17 minus, and we have gallons used. Hopefully this should make sense. Gallons used all over hour. Well, how do I figure out those units? I want hours in the bottom. Well, I've got 50 miles per hour. 50 miles per hour. Okay? And I'm going to multiply by, I want to get gallons on the top. Well, here I've got, where was it? 21 miles per gallon. So if I wrote that over here, 21 miles per gallon, what's the only problem? Gallons is in the bottom. So we're going to flip it. And we got 1 gallon every 21 miles. So look what happens. Miles over miles cancels out, and now we have gallons over hours, and that was gallons over hours, which is going to turn out to be 50 over 21. And we can add our time in there, which was T. So that's going to be 17 minus. That's another way to get to choice B. But I like the other way better, considering that as the time gets bigger here with the T in the denominator, you're actually using less and less gas, which doesn't make any sense. So hopefully that made sense now, and you can get that problem right. Okay, take care.